Okay, anyway. So packing crate of mass 4 kg. So there is a crate of 4 kg on the horizontal ground. It's filled with books that are evenly distributed throughout the crate. Coefficient of friction between the crate and ground is 0.3. Find the mass of the books if the crate is in limiting equilibrium under the effect of horizontal force 147. So let's start. Again, we have a crate, so let's draw it as a crate. Okay. Then on top of this, we have books. Coefficient of friction between the crate and the ground is, so mu is 0.3. Mass is 10 kgs. So mass, let's bring it down, 10 g, correct? So packing
Yes.
crate is 10 kgs. It is filled with books which are evenly distributed. Book mass of the books is not given now. So mass of books, let's call it as mb. If m, let's say m is the mass, so g will be multiplied. So m kg is the mass of books. Coefficient of friction between the ground is 0.3. Find the mass of the books with the crate is in limiting the effect of. Okay, so if you apply, if you crate is in limiting equilibrium. So on the crate we are applying a force. How much? 147 newtons. So when we apply a force 147, it is coming under what is that? Equilibrium, limiting equilibrium. So that information we need to use. So let us say this is the normal reaction. This will be how much? How much, ma'am? Friction is this much, so 0.3 times r. Because in this case, he is telling that the object is in limiting equilibrium, no? Limiting equilibrium means we have to take whatever friction is there here. So okay, that's it. Now find the mass of the books if the crate is in limiting equilibrium under the effect of, okay, so 147. So 147 newtons is bringing it in equilibrium. We have to find what? Mass of books. That means m we need to find. Okay.
Yes.
So m we need to find. So ready? Let's go ahead and find m. So again, you have to do vertical first, no? So now y, r is upwards, minus 10g and minus mg equals 0. So r equals 10, sorry, 10 minus m times g, na?
Yes.
So r we found. So in sigma x, take all the horizontal components. So 147 minus 0.3 times r, correct?
Yes.
And that's all. So this total should be 0 again. So r equals 147 by 0.3.
Yes.
So r we found. What did he ask us to find? M, na? So 1 minute, sigma m, sigma r. So r is equal to this. So if you substitute r here, what do we get? Implies that 10 minus m times g equals 147 by 0.3. What do we get? We get the value of m as 147 by 0.3, and by G and 10 minus this, no?
Yes.
Because we have 10 minus m comes this side, so 10 minus 147 by, what do we get? Ten minus 147 by 0.3, so minus 39.95. How can it be
Yes.
minus? It shouldn't be minus. Something has gone wrong. Here both of them are negative, no? So it becomes plus on the other side. Okay,
Yes.
so plus here. So this goes on to become m equals 147 by 0.3 G minus 10. So what do we get? We get 39.95 positive.
Yes.
So this is in newtons. No, not in newtons. It is in kgs now. Because G also is divided. After dividing with G, we will get in kgs. Okay.
Yes.
So first bit clear.
Yes, sir.
And state whether modeling assumption, what modeling assumptions you have made. Okay. So what modeling assumptions have we made? He is already telling it is stationary. So normal reaction is normal to the surface. That is one assumption we made. And what other assumption? So this is the friction law, no? Mu into R
Yes.
is friction law, that is limiting friction. So that is another assumption we made. Okay,
Yes.
so this question is clear. Any doubt?
No.
Okay.